Thanks for joining us for this Vulcan webinar. My name is Mike Husbands. I'm the National Technical Services Manager for Maptek Australia. Today, Richard Jackson continues our webinar series with a spotlight on Grade Control and Vulcan. In today's webinar, you'll learn how to use Vulcan Grade Control to streamline your workflow and maximise the value of your blasts. This will cover general tips on setup and reporting, and you'll see how the Grade Control Optimiser can fit into your workflow to maximise profit. If you have any questions during the webinar, you can enter them into the questions panel on the GoToWebinar interface, and we will answer as many as we can, time permitting, at the end of the session. Over to you, Richard.
Thanks, Mike. Good afternoon, and thank you to everyone joining us today. I'm a geologist and a Vulcan Technical Services consultant for Maptek, based in New Zealand, and have worked with many clients throughout the Asia Pacific on their grade control systems. And today I'd like to share with you some tips to ensure you are getting the most value out of Vulcan Grade Control. The reason we undertake grade control is to define the material or destination boundaries within our blasts, and the decisions we make when defining these material boundaries ultimately define how profitable our blasts will be. Because the grade control process usually takes place under pressure to get the blast signed off and the material to the mill, we need a robust but time-efficient process while building in checks to ensure we are making optimal choices for the position of each grade block within the blast. Today we're going to look at some tips to help streamline your grade blocking process, material reporting and how reporting misclassification will validate the chosen position of your grade block boundaries, and finally we'll look at the Grade Control Optimiser and how this will fit into your grade control system to increase productivity and ultimately profitability. The grade control menu has been designed to help streamline the process with options grayed out that aren't applicable to the way we've set up our particular grade control. So if we look at the option here for sample source setup, that's not applicable from the way I've set up my grade control database, where I'm reading from a grade control block model rather than an on-the-fly created block model. Also helping us with the grade control process, the options that aren't available or aren't applicable for where we are in the steps are grayed out. So I can't yet create my grade blocks because I haven't loaded or created a blast. What I'm going to do is run through making a few blasts and a few tips before we start looking at reporting and how we can check how well we're doing with our blasts. So I'll make a new blast. This is blast 1 on the 5000 level. And to define this, I'm going to use one of the newer options, which is to use a top and bottom surface. So if we don't have perfectly flat blocks, it may save us time rather than having to make a solid how we would have in the past. So using those surfaces, it's going to project them vertically, but we could change that angle, essentially making a solid on the fly to define the blocks. We'll have a look at what we've got here to use in our grade control. So on the screen, I've got my gold labeled, my profit per ton. We'll have a look at where we might use that shortly, and also the material type. So this is a gold deposit, and the material types for this particular bench are just high grade, which is going to be a direct mill feed product, a low grade, which will have a bit more cost associated with rehandle as it goes to a stockpile, and then some waste. So typically the geologist is going to look at either one or more variables, design, and where these block boundaries might be. So cutting across the waste there, I might cut through this low grade area here, but when I come up to the edge of the block, I need to keep an eye on my minimum mining widths. Often to do that, I'll use my custom cursor, and I've just got that set up to be twice my minimum mining width, so that the position from the cursor to the edge of the circle, the radius is my mining width. Or in other words, as long as I keep the circle away from the green line, I know I'm fine. So I'll have a grey block through there. I'll cut off the waste through here, and perhaps I've got a low grade area up through here. To help check how well I've done, I'm going to run the blocking process. So I'll create my grade blocks from these lines. You'll see one of the options in there is to use triangulations. So if you do have any angled trim blocks that things aren't vertical, you could use that. Or if you did have a fault coming through, you could pick a triangulation or give one of the lines an angle, but these are all vertical. I'll just label them from the north. And if I just change my coloring to my material, which is showing me my high grade and low grade, these two red blocks indicate they're both high grade. So even though there was some variability, it hasn't been enough to change the designation to low grade. So perhaps I'll reblock it without that particular block boundary. Also of concern is what the effect of having this waste that I put in for minor constraints, what the effect of that will have on this low grade block. So to help identify how much misclassified material is in each block and the effect it's having on the grade and profitability, we can use the material reporting. You'll see in this new grade control, all of the setup panels have been put off to the side with all of the sort of process panels or options down the main menu. So in this material setup, if we look at how I've set it up, you can see I'm not breaking it down by a true material type, instead using this profit flag. And the reason I'm doing this rather than breaking it into my high grade and low grade boundaries is because I'm not so concerned if a little low grade is mixed in with a high grade. I'm more concerned about seeing the effect the waste is having on the ore blocks and how much that's diluting them. And we'll see how I've set up this profit flag shortly. So with this profit flag, I've set this up in my calculation rules. So that is on the fly calculating whether it's a profitable or non-profitable block from the block model and a profitable or non-profitable blast block. So that profit flag down here is just set with a simple calculation. You will notice that we now have available the scripted rule format. So the same kind of if statements that you're used to if you're using block models. So profitable blocks are flagged as profit and everything else, non-profitable blocks, are flagged as loss. And this is important in the way that I'm choosing to break down this next report. So I'm going to run this material report. It makes a few report types and I'll show you what useful information we can gain from them. But it's really about showing us how much misclassified material, and in the way I've set this up, how much loss is being added into my profitable blocks. So the block in question, that low grade block, was block B. And I can see that I've got 20% loss blocks in that, which might alert me that I could perhaps block it a little differently and reduce the amount of dilution. In the dilution report, we can see the effect this has on grade. So without that without that dilution, we would have an average grade of 0.63 grams per tonne, but that's been diluted down to 0.52 grams per tonne. And finally, in this dilution breakdown report, because I've chosen to specify my profit per tonne, so that's being represented here as $11 per tonne. So the mineral in this case is really the tonnes times the grade, or the tonnes times the profitability. So that is my total dollar value of profit and loss for that particular block. So the combined together, the cost of extracting all the non-profitable blocks with the profit generated by the profitable blocks. I'm losing almost half, or just more than half, of the value of that blast, or that particular block in that blast, losing that to dilution. So putting that aside, I might choose to go back and check if I could cut this any other way to reduce the amount of dilution, and still keeping an eye on my minimum mining widths. If I bring this block boundary up here, that will reduce some of the waste. Now, you're never going to be able to get rid of all the waste if you've got a few waste or low grade blocks inside a high grade block, but we should be able to minimize it and see the effect in that report. I'm just going to bring these block boundaries across here so we don't get multiple waste blocks, but we could always keep them as separate waste blocks. One of the things to be aware that you can do in the current grade control is not just use lines, but use polygons. So we could have defined this low grade area in a polygon. I'm just going to reblock the blast. Run through the process of creating the grey blocks just as I did before. Keeping my naming the same so I can compare block B with block B. And if I run my material report again, hopefully it will show us that we have less dilution and the effect of the value of the blast because of that. So block B, what was going to make us $100,000 is now making us $186,000 as I've lowered the dilution down to 5.6%. So it's a really handy tool for just validating that you are putting the block locations in a good place. So while we can take care to draw the block boundaries with attention to all the dependent variables and the minimum mining widths, two geologists doing the same blast are almost certainly going to give slightly different block boundaries. If you want consistency in the process and the optimum position of the blocks to be calculated first time, the Grade Control Optimiser can really speed up your process and potentially increase your profitability. This Grade Control Optimiser has come in 10.12 as a new tool for optimizing the location or the destination of all the blocks based on some economic constraints and the mining width. So in this case, I've got 6 meter blocks, keeping my 12 meter minimum mining width. The input can either be multiple economic variables, which is what I've got set up here. So in this case, I have 3 different economic variables. For the same block, I might lose $200 if I send it to waste, so the cost of extracting that block with no profit. If I send it as direct feed to the mill as a high grade block, I might make $1,000. But the same block, if I send it to a low grade stockpile and I have rehandle, perhaps I'd only make $800. So this optimizer will look at all that as well as the mining widths and decide what block should be taken where. If you've got a single variable that stores the destination, so the destination you've already assigned in your block model, you can pick it up here, and you can set up a matrix of if you will allow a certain material to go to a different destination and what proportion you'd like it to go to one destination as opposed to another. You can set that up. Of course, if you don't have a block model, if you're doing the grade estimation on the fly inside grade control, it can also pick it up here, looking at those on the fly destinations and do that optimization. So I'm going to run this now. It's doing it on my bench, so it does it on a bench by bench basis. I haven't restricted it to one blast, but there is options you could do if that's how you want it to run it. If you are interested in some more information on how this is set up, there's a great webinar called How to Classify Material with Grade Control Optimiser, and we'll show you at the end of this where to find our other webinars. So that's optimized into a new variable in the block model, and we can pull out the polygons from that. So it's pulling it out from that level in the block model. I've got a legend set up so it colors them with my low grade, high grade and waste colors. There are some options around smoothing and limiting polygons, but I'm just going to run it for the whole bench. So if I turn off my blocks to make things a bit easier to see, you should see it's defined the waste in a similar way, although a little more optimally on that boundary. It's taken the high grade boundary a little tighter than I had manually, which is again taking it directly off the best position from the blocks. And it's also picked out a few low-grade blocks on the side here. This is a great starting point for grade control, but we don't have to run these polygons exactly from the optimizer. So in this case, keeping an eye on my minimum mining widths, because I haven't restricted this just to a particular bench, or sorry, a particular blast. It has got blocks that are mineable, but not inside my blast. So I'm going to choose not to use these. So just take this as a single high grade area. If we wanted to move any of these points, we could do so. So based on any geological knowledge or any additional mining constraints we have for a particular blast, we could move them around. But the key thing here is it's giving all the geologists the same starting point, the same polygons that they can edit for the grade control, rather than making all these original decisions themselves. So what I'm going to do is run this through grade control. I'm going to make a new blast so I can compare it with the manually made blast later. So blast 2 at the 5,000 level. Stepping through with my same process. Making that, or defining that solid. Let's turn on my blocks there. And you can see how it's tracking the high grade, low grade boundaries and filtering out or optimizing that these low grades do need to be taken as they don't reach the minimum mining width. I'll run this into my grade blocks. Keeping my numbers the same. So it's generated my grade blocks there. One of the things that I might like to do to compare is compare how this high grade block from my manually created grade blocks compares to my optimized block. So I'll just save this old report so it doesn't get overridden. And run my material report. Again, of these 4 reports, it's the dilution breakdown, which is giving my total value for my blast. So for any profitable blast, we can read that as the amount of loss and the amount of profit with the total value. So for the grade block C, which was my high grade block, that's, if I count my decimals, $1.84 million and $1.71 million when I did it manually. So if I get my maths right, that's about $125,000 of additional value. Now we can't just treat this as that is the additional value of the entire blast, because if we have increased the tons, taken some out of the low grade, we're going to be increasing the value in one block and decreasing it in another, even though high grade does have in this case, a higher profitability than this low grade rehandle product. What we can do to help check what's going on here is have a look at the blast report. And as I've got 2 blasts up at once, I can compare the 2. So all blasts, reporting my materials, my gold grades, and my profit. Putting in some averages and some columns to make the report easier to see. So that's just generated that. And if I just open that up, so what we have here is blast 1 at the 5,000 level was the manually created blast. Blast 2 was the optimized. So the difference in value is $14,000 additional value from that one blast. So the same dirt that we've blasted, just choosing more optimal locations to send the different products, we've increased the profitability by $14,000. And if we think about that on a week by week, month by month, and then the total pit, we have potential to generate more value from the same ground. So with a Grade Control Optimiser, we need less back and forwards between creating and checking the block boundary locations. We get the optimum location right the first time, but we can still adjust the position as needed. It's quick, repeatable, and in this case, it's increased the profitability of the blast, and ultimately that's the most important thing. Well, that brings me to the end of this demo. Mike, back to you.
Thanks for the run through of Vulcan Grade Control features, Richard. What Vulcan modules do users need to access these new tools?
So in this demonstration, I've used two modules. The bulk of it was looking at the Grade Control module and all of the blocking that goes with it. The Grade Control Optimiser is a second module, so if anyone's interested in that, contact Mike, myself, or any of the Vulcan technical support people.
Okay, so we've had a few questions come through. The first one, Richard, is you've shown this in an open cut application. Is there any application in Underground?
Absolutely, Mike. So the starting point of this is a triangulation, and we could use a solid triangulation, which might be a stope. Anytime that you have the ability to cut up your stope or your ore block and send different parts of it to a different destination, you have the chance to optimize your value you're getting from it, and you could certainly use that in Underground.
Great. Okay, next question. I think you may have touched on this. The Grade Control Optimisers run off the block model in your example. Can it be run across the samples database?
Yes, you can. So it's a new option that's come in the last few versions, that you can use the same on-the-fly block model that you can in Grade Control. So that's reading directly from your samples, doing the estimation, and doing it at that stage. Something else worth pointing out there is new in 11, which should be released in the next week or announced in the next week, is the option to have grade estimation scripts, not just powered by Perl, but also now by Python scripting.
Great. Thanks again, Richard, for the showcase of the Vulcan Grade Control features. That's all the questions posed to us. If there's any further questions, then please send them through to your Maptek office. So customers with current software maintenance can download the latest version of Vulcan from the users.maptek.com website. The latest version is 10.1.6, which is available now. Keep an eye out for Vulcan 11. It's coming very soon, and a notification will come out shortly, as Richard mentioned. Of course, if you have any questions about Vulcan, please contact your local Maptek office for assistance. You can find all relevant details for contacting us on our website. And if you'd like to view this webinar again or share this with your colleagues, it will be available online at maptek.com. While you're there, you can catch up on our other webinars covering a whole range of topics, including that other webinar on grade control that Richard mentioned. We'll also be running additional webinars about other topics in the near future, so keep an eye out. Thanks again for watching.